Hello everyone and welcome back. So let's continue to integrate rational functions using partial fraction decomposition. Alright, so we are going to move into the case where we have repeated linear factors and we want to integrate that rational function. Okay, so what I'm going to do is first you're going to do the decomposition, right? As you can see clearly here, x plus 2 square. So x plus 2 is a repeated factor, right? So what would be the decomposition? Can you remember? So it's going to be a over, let's deal with x plus 3 here, right? Plus b over x plus 2. So that's for x plus 2 square, and you know we have to count up to 2, right? So now we have to represent c over x plus 2 square. We have to represent x plus 2 square, right? So this is the decomposition. Now we have to find numbers. So in this example, I'm not going to teach you how to find numbers. I'm not going to show you how to find the numbers. I will give you the numbers, but in the next example that I do in this video, I will show how to solve a full problem. Okay, so let's first focus on integration here. So the numbers will be, these are the numbers. Now here's something that you can do. Pause the video and try to get these exact numbers. Try to see whether you can do the decomposition by yourself. Evaluating the constant by yourself and see whether you get the same answers. Okay, all right. So given the decomposition, assuming that you have the complete decomposition, how are you going to integrate? Okay, so that's the focus on this first example. All right, so now you have to integrate. So integrating the left hand side is same as integrating the right hand side, right? So that's the whole point of decomposition. So we can separate this integration. So we can first integrate 11 over x plus 3 minus 10 over x plus 2. We can integrate that separately, and we can integrate this one separately. All right. Okay, so the first two parts you know how to integrate, right? We saw that in the last video. So here if you integrate 11 over x plus 3, it's going to be 11 natural log absolute value of x plus 3, right? We already know that. Here minus 10 natural log absolute value of x plus 2. Oops, absolute values, okay? Plus here, yes, it's going to be natural log x plus 2 square, right? Because it look like previous problems that we have, right? Previous integrals that we have. Okay, so is that correct? So that's the biggest question mark. This is one of the biggest mistakes that I have seen in partial fraction decomposition. Okay, I showed you a big mistake, the first mistake that you do in the partial fraction decomposition in the previous video, right, with the integration. Now here's another thing. Now this is incorrect. So why is that? So integrating 1 over x plus 2 versus integrating 1 over x plus 2 square is two totally different things. Okay, this is a linear factor, x plus 2 to the power 1. Then you can use natural log. So if you integrate 1 over x plus 2, yes, it's going to be natural log absolute value of x plus 2. Okay, but if it is not linear, if there's a power, well, then you don't use natural log anymore. Okay, I have discussed this in my basic integration video series. So if you have forgotten that, go to my basic integration video series. You can find the link in this video on the top. Okay, so go to that video and recall. But the idea here is you cannot use a natural log. You don't use a natural log when you have a power other than 1, okay, in the term of the denominator. So how do you integrate? So this is wrong. How do you integrate 6 over x plus 2 square? So it's very simple again. So let's take that 6 out. So you want to integrate 1 over x plus 2 square. Now think about 1 over x square. How do you integrate 1 over x square? Take x square to the numerator, so you can write it as x to the negative 2. Then just integrate it as integrate it normally, right? The integral of x to the negative 2 is x to the negative 2 plus 1 divided by negative 2 plus 1. It's that simple. Okay, so you can do the same for x plus 2 square. All right, so let's do that. These answers can stay there. 11 natural log x plus 3 minus 10 natural log x plus 2. So here 6, I can take x plus 2 to the numerator, so x plus 2 to the negative 2. Okay, now integrate just like you integrate x plus 3. So x plus 2 plus 6. So if you integrate x plus 2 to the negative 2, it's x plus 2 to the negative 2 plus 1 divided by negative 2 plus 1 plus c. So let's simplify and write the answer. So here I always forget this 11 natural log absolute value x plus 3 minus 10 natural log x plus 2 plus 6. So here this will be x plus 2 to the negative 1 over, oh, this is negative 2 plus 1. So negative 2 plus 1 is negative 1. So we can write this as negative 6, right? 6 over negative 1 is negative 6. So we can write x plus 2 to the negative 1 as what? 1 over x plus 2, right? X plus 2 to the power negative 1 is 1 over x plus 2. X plus 2. Okay. Plus c. Alright. So this is the solution. Alright. This is what you get after integration. Now the important thing again, how do you integrate repeated factors, repeated linear factors, so they don't involve in any natural log. Okay. So if you have linear factor, just linear factor, okay, power is 1, then you use natural log. But if you have repeated factor, that repeated term, repeated power, then you have to use the power rules. Okay, you take it to the numerator and then you integrate. So same for x plus 2, 1 over x plus 2 cube, then you take 1 over x plus 2 cube to the numerator, so it becomes x plus 2 to the negative 3, then you integrate. Okay, so that's why I wanted to do this video separately. First video just distinct linear factors, now repeated linear factors. In the next video we will see irreducible factors. How do we integrate that irreducible part? Okay, so we can move on stepwise. Okay, so as I promised, let me show you how to do a full problem. So my full problem is you have to integrate 9 over x plus 1 square x minus 2. You know what best to do? Pause the video and try to do the problem by yourself and then compare the solution with me. Alright, so let's do the decomposition. So 9 over x plus 1 square x minus 2. The decomposition is a over x minus 2 plus b over x plus 1 plus c over x plus 1 square, right? Alright, now to find a, b and c, you multiply both left hand side and right hand side by this big denominator. So on the left we will have 9 a x plus 1 square plus b x plus 1 x minus 2 plus c x minus 2. Alright, so now we want to find a, b and c. So we can use a magic number. If we use x is equal to 2, left hand side is 9. So a times 2 plus 1 is 3. So 3 square is 9. So a times 9. This term vanish, this term vanish. So when x is equal to 2, b and c vanish, right? So a is actually 9 over 9, 1. Oh, nice. And then let's use x is equal to negative 1 so that we can find c. So left hand side is 9. So this term vanish, b term vanish because x minus 1 plus 1 is 0. So c times minus 1 minus 2 is minus 3. So it seems to be like c is going to be 9 over negative 3 is negative 3. Perfect. Now we want to find b. So what can we do? So you can use couple of methods here. So you can expand the whole thing or just use another number. We don't have any other magic number. So let's use like what? 0. Okay. So when x is equal to 0, a times 0 plus 1 is 1. So it's just a. Plus b times 0 plus 1 is 1. 0 minus 2 is minus 2. So it's minus 2b. And here c times 0 minus 2 is minus 2. So it's negative 2c, right? Okay, so we already know a and c. A is 1 minus 2b. C is negative 3. So here positive 6, right? So 9 is equal to 7 minus 2b. 6 plus 1 is 7. So take 7 to the other side. So it's 2b. 2 is equal to 2 negative 2b. So it seems to be like b is negative 1. Alright, so we found all the constants. So let's write the full decomposition. A is 1. So 1 over x minus 2. B is negative 1. Negative 1 over x plus 1. C is negative 3 over x plus 1 square. Alright. So we want to do the integration. Okay, I'm trying to find space. Alright. So we want to integrate 9 over x plus 1 square times x minus 2. Right, integrating this is same as integrating 1 over x. The decomposition, minus 1 over x plus 1 dx, and I'm running out of space, 3 over x plus 1 square. Right, okay, so we can integrate these three terms separately. Okay, so I found space. Perfect. So what's the integral? So integral of 1 over x plus 2 is natural log absolute value of x minus 2, right? Not x plus 2, x minus 2. Minus the integral of 1 over x plus 1 is natural log absolute value of x plus 1. They are easy. We already know that. So here the integral is minus 3 comes out, right? So let's do this integral separately. So we have to integrate 3 over x plus 1 square negative, right? So 3 can come out, so inside can be written as x plus 1 to the negative 2. So negative 3, if you integrate x plus 1 to the negative 2, x plus 1, negative 2 plus 1 divide by negative 2 plus 1 plus c. So the final answer is natural log x minus 2 minus natural log x plus 1. Negative 3 over negative 1 is just 3. And x plus 1 to the negative 2 plus 1 is negative 1, so we can write it in the denominator, x plus 1. So yeah, there we go. So plus c, don't forget that. So this is the full answer, okay, once you integrate what I gave you. All right, okay, so that's how you integrate linear repeated factors, so a problem with linear repeated factors. Okay, all right, so in the next video, as I promised, let's learn how to integrate a problem with irreducible factors. Okay, all right, thank you.